So hey everybody, I'm Miriam. I go by Ace. Forgive me if my voice is kind of low or I'm slurring a little bit. It's a 10:04 and it's been a long day, but nevertheless, we're reading chapters 4 through 6 out of one of my favorite books so far. Materials. Yeah, for this class. Anyway, so I chose to choose Ash Fly Concrete. I'm a tree hugger, and I will use it in the design of any type of structure because it has an aesthetic and appeal that I particularly like. That it's not only denser and smoother on the surface, which might appeal to the client, but as an architect, I choose something that is near and dear to my heart, which is anything that is recyclable. That's for Mother Earth. So this product in particularly is a post-industrial material, and it is considered a green product partly because using it in concrete reduces the pollution by keeping it out of the landfills. So also these recovered gases are created by coal-fired electric power generation. Fly ash is basically that what we see out of the power plants when the coal is burnt. A lot of hydrocarbon cracking, and also that goes into getting these carbons out of the earth, and a lot of that is emitted, and most of it actually is, excuse me, that is killing me. Most of it is emitted back into the earth. So if we can gather that, it's better for us. Anyway, moving on, functionality. Provides an economical and environmental substitute for Portland cement. So as you see here, I use a little graph here I liked, a pie chart actually, and it just shows you, a couple of things, the benefits of fly ash. One in particular, it increases mix stability, and I also like it increases the ultimate strength. And it reduces chloride ingress and increases sulfate resistance. So in a nutshell, it's a substitute for Portland cement. It's actually a byproduct of it, and it's used in the production of concrete, brick, and block. Next, we have the structural integrity and durability. And this particular concrete byproduct, fly ash, has a particular shape, very circular. As you can see here, as in this diagram that I put up for you guys, and it shows that it has a good consistency and workability, and overall giving it a higher strength, and it has the potential to bleed less than the Portland cement. Let's see. Moving on to reaction and relationships. It being fly ash again, is consisting of most of silica, iron, and alumina. And I have a picture of here, fly C ash and fly F ash. Fly C ash is resistant, to expansion from chemical attacks, and fly F ash ash reduces the risk of sulfate attack. And in a nutshell, when stamping concrete, fly ash can buy the time necessary to adequately texture the surface. So its drying time gives us a time to level out and smooth out the surface. So, I mean, the more time that we have to do things, we have better accuracy, in my opinion. So there's no rush. We get to do it right, and let's do it right and tight the first time. Fly ash is also better for the client because it's less expensive than cement, and it's also just as strong. And so the mixes that are contained in it are usually a bit less expensive, again, than the straight cement counterparts. And last but not least, problems faced due to fly ash. There's always pros and cons. I wanted to include those. Fly ash affects the ecology of the land, water, and air in the region. Pro. Fly ash causes ailments like allergic bronchitis and asthma, which is not good, obviously. And the World Bank, just a fun fact, has cautioned India that by 2015, disposal of fly ash will require 1,000 square kilometers in its report on environmental issues in the power sector. So out of the total bricks, 50% of the ash bricks we will use And to reduce emission of greenhouse gases, we need to use 435,000 tons each year. So, I mean, we need to get with the program. But again, this is Fly Ash, and this is Miriam, and you guys have a good day. Thanks for watching. Bye.